Hello students, in this video we are going to discuss section C, 3 mark questions from question number 22 to 24. Identify the sample circuit elements X and Y as shown in the given block diagram and draw the output waveforms of X and Y. Here the X is corresponding to full wave rectifier. So here AC input is given, we are getting the output. Y is acting as like rectifier. Now we need to draw the waveforms of X. The waveforms of X and Y can be taken like this. So this is output voltage, suppose if you are considering, or current for X with the time. So this output will be this one will be like this, the voltage with same direction but varying the magnitude. Now while coming to the rectifier, these are pulsating output. We have to smooth these pulses. This one has the AC components as well as DC components. Output voltage or current for rectifier. Here so this output will comes like this, almost constant. This is the answer for this output forms of X and Y. If the center tapping is shifted towards diode D1 as shown in the figure, draw the output waveform of the given circuit. If you observe, this center tap is shifted towards D1. Suppose if I am taking, this is the point C, then the potential difference between A and C is smaller with compared to the potential difference between B and C. That means while we are getting the output from the diode D1, it should be the pulse with the smaller amplitude. While we are getting the pulse from D2, the pulse amplitude should be larger. So if I am drawing the waveform, it is output voltage and time. Suppose say first of all D1 is under forward biased, the pulse will be like this, and for D2 like this, for D1 like this, for D2 like this. So this pulse is due to D1, this is due to D2, D1, D2. If you observe, the height due to D2 should be same, the height due to D1 should be same. Find the expression for the capacitance of parallel plate capacitor of area A and a plate separation D when a dielectric slab of thickness T and a metallic slab of thickness T, where T is smaller than D, are introduced one by one between the plates of the capacitor. In which case would the capacitance be more and why? First of all, I am taking the first one, whenever dielectric is introduced between the plates of capacitor. This is parallel plate capacitor having the charge Q, and separation between them is D, and the area of the plate is A. Now This gap is filled with a dielectric slab of thickness T, having dielectric constant, suppose say K. Now, the electric field within vacuum or free space is C naught, where there is no dielectric. So within the dielectric, E value will be is equal to E naught by K times. So generally, the expression for the capacitance C is equal to Q by V. Now here I am naming it is C1. Take it as equation number 1. So V is equal to, we can write E naught into D minus T. That means if you remove T from D, the rest of the part is having the electric field E naught. So the potential difference there will be E naught into D minus T plus E into T is the potential difference within the dielectric. We can write it is E naught into D minus T plus E is nothing but E naught by K into T. If you are taking E naught is common, that is a D minus T plus T by K. And this E naught is nothing but sigma by epsilon naught, the electric field in terms of surface charge density, D minus T plus T by K. That is nothing but sigma, again if you are writing in terms of charge, Q by A into D minus T plus T by K. So this is the voltage whenever dielectric is introduced. Now, by putting this equation 2 in equation 1, the capacitance C1 is equal to Q by A epsilon naught into D minus T plus T by K. Q will be get cancelled. Then that is equal to epsilon naught A divided by D minus T plus T by K. So therefore, C1 is equal to epsilon naught A divided by D minus T plus T by K. If you want, you can take it equation number 3. Second part, if metal or metallic plate is introduced, metallic plate alone, then for the metals, K value will be infinity, and I am writing this capacitance differ with compared to equation 3. From equation 3, epsilon naught A divided by D minus T plus T by infinity. This is simply epsilon naught A by D minus T. You can name it equation number 4. From equation number 3 and 4, we can write C1 and C2. C2 will be more than C1 as D minus T is smaller than D minus T plus T by K. That means if you are taking this metallic plate or metal inside the capacitor, inside this metal E value is 0. That's why definitely C2 will be more than C1. Draw a ray diagram for the formation of image by Cassegrain telescope. So this is nothing but reflecting type telescope. Here it contains objective mirror. When the rays are coming from the object which is at infinity, they are parallel to each other. They are incident on the objective mirror. They are undergoing the reflection and again incident on the secondary mirror. The secondary mirror is nothing but convex mirror. They are again reflected and finally the image is formed. For this diagram, along with the labeling, 2 marks given according to the CBSE sample paper. It may vary slightly. And two applications are two advantages over why these type of telescopes are preferred over refracting type telescope. Any two applications we can write. It has the mirror objective, so which is free from chromatic and spherical aberrations. So aberrations won't be takes place or can be eliminated by using this. One more, it can gather more light as objective can be made larger, hence the image can be brighter. So these are the two advantages over refracting type telescope. So you can add some more points also. Thank you. In the next video, we will discuss 25, 26, 27 and 28. So please subscribe the channel. 100% it will be helpful for you for your board examination. Thank you.